Hi, this is Margo. This is Sunday, early evening, August the 22nd, 2021. I hope everyone is safe and doing as well as possible. We made it through another week. It was a hard week for me. I don't know how it was for everyone else, but I'm here. I'd like to welcome everyone to the show today. This will be my weekly update that I'll be putting on YouTube. We're going to go over methane, sea ice, and earthquakes and Climate Reanalyzer, usual things. I'm going to start off, if you want to see the smoke where I live, this is Zoom Earth. It's still light here, but it looks like it's getting dark. There are massive fires burning in California. There's a new one that just came up a few days ago down here, South Lake Tahoe, called the Caldor Fire, and I'll turn the fires layer on. And it's, now it's at 5% contained. It's already burned 104,000 acres. And we are in the direct hit of that smoke coming all the way up to Reno and beyond. And then up here around Lake Almanor, this Dixie fire has been burning for a month or more now, and that's, what is that at? 37% containment. That's burned over 700,000 acres. Then we've got more up further north. But we've been getting smoke here in the Reno area about every day, and we can't see the sun. And I've had to go out to appointments in this, and it's just very hazardous. And so that's my story. Here it was at noon today. See, as the day goes on, see, it gets more dense. Look at that. There it is at 3 p.m. Here's 4 p.m. See, you can't even see anything there. Here's 5 p.m. and so on. So that's what it's like where I'm at. And I hope, I know Russia is on fire, but look at how this smoke is just moving out across all the country. And anyway, so that's what we've got here. I've got an article I want to share. It's regarding the rain that fell at Greenland last weekend, and I posted it on my community page, but I want to go over it in case anyone missed it. This was published on August the 19th, Thursday, from CNN. Rain fell at the normally snowy summit of Greenland for the first time on record. There's a picture. For the first time on record, precipitation on Saturday, meaning last Saturday a week ago, at the summit of Greenland, roughly 2 miles above sea level, fell as rain and not snow. Temperatures at the Greenland summit over the weekend rose above freezing for the third time in less than a decade. The warm air fueled an extreme rain event that dumped 7 billion tons of water on the ice sheet, enough to fill the reflecting pool at the National Mall in Washington, D.C. nearly 250,000 times. It was the heaviest rainfall on the ice sheet since record keeping began in 1950, according to the National Snow and Ice Data Center, and the amount of ice mass lost on Sunday was 7 times higher than the daily average for this time of year. Raise the sea level too. So I'll leave the link below if you want to check out this article. But this is extraordinary, and we will be seeing more and more of this happen as things warm up in the Arctic, and especially with the methane going off the chart, and it went up again this week. And I'll show that in a second. But let's see. What else was I wanting to show from this article? They've crossed thresholds not seen in millennia, and they say that it's not going to change until we adjust what we're doing to the air. Well, the only thing that's happened is it's gotten worse. So I pulled up where this is. It's right in the center of Greenland. That's at Summit Camp. There's a research facility there, and we hardly ever see melting here. And if we zoom in, here's the camp. And it's manned year-round, and here are the buildings. This looks like an airplane. This looks like where the airplane has done some landing or takeoff, or I don't know what that is. Anyway, we've got buildings, a couple of buildings. But this is the camp. Houses up to 38 people in the summertime and just a few people in the wintertime. Want to get away from it all, come and work at Summit Camp. So I thought I'd show you that. Now, let's move on. We'll go over methane next. I'm going to start with the NOAA methane data from yesterday, the 21st. This is for the 477/469 millibar reading. METOP-1, which has been renamed METOP-B satellite in the morning. The mean or average was 1930 parts per billion. Now that's the highest we've seen the mean so far. It's been, all of these numbers have been just going up all week. The high reading was in the range was 2363. The pink area is the highest in the range between 2000 and whatever this highest number here. So here it's 2000 at 2363 parts per billion. And we've got pink all over the northern hemisphere and also across a lot of the southern hemisphere, especially around close to the Antarctic coastlines there. In the afternoon, the mean was 1930 as well. The high reading was 2362. On the METOP-1 satellite, renamed METOP-A in the morning, the mean was 1908, the high reading was 2346. Now we've got a lot of missing data here, but we're going to take the reading. In the afternoon, the mean was 1906, and the high reading was 2288. Here's the spreadsheet and chart where I've been tracking this since March the 1st of 2019. We're in the middle of the warming time, and the time when methane typically is on the rise. It goes through a seasonal cycle, and it'll peak out usually around October is what we've been seeing, and then it starts going down. So here for the 21st, we averaged it out to be 1918.5 parts per billion. That's showing an increase for the whole week of 5 parts per billion. And here we are. See the line, this blue line going straight up here. And when I did the insert chart on here, instead of the 10 increments of 10 on the lines, it changed it to increments of 20. So I don't know why that is. Maybe because it was going up so fast. Possibly. Because we went up on the 7th, we were at 1909.25. On the 14th, which was in my show last week, we were at 1913.5, and that was an increase of 4.25 in 1 week. And then this week, an increase of 5, so almost an increase of 10 parts per billion in 2 weeks. So that's crazy. We're 23.25 parts per billion higher than we were a year ago. And we're 61.25 parts per billion higher than March the 1st of 2019. So it really seems that methane is going exponential, especially with the wildfires that are burning in Russia and the permafrost that's burning and releasing so much methane. But we're seeing higher readings all around the planet. And as a result, it's going to heat things up. It changes everything. Now let's see what happened this week. So here we were at our show last week, and for Saturday we were at 1913.5. Sunday it went up 0.5. Monday it went up 1.25. Now Tuesday we had a drop of 2.75, and I put a note over here, questionable data for the PM readings, and on the afternoon readings for both Met-Op 1 and Met-Op 2, they were a lot lower than what they had been, and there was a lot of missing data. It was about half gone. And so in my show that I posted during the week on Subscribestar, I said that I felt like this was a false decrease because of the missing data. And sure enough, then the next day it hopped back up and jumped up to 1915.75. So that was an increase over the day before of 3.25. But if we had not counted that day with the missing data, it would have been an increase of 0.5. And then on the 19th, we went up 2 parts per billion, so that was a huge jump. And then it stayed up there. Look, it was at 19, I forgot, it was at 1932 on the Met 1 in the afternoon. And then on the 20th, 1918, so an increase of 0.25, and then on Saturday an increase of 0.5. So here we are, 1918. And this is at the 477/469 millibar reading, which is about halfway up in the atmosphere. So at this rate, we're going to blast through. We blasted through all this from 1910 up to 1920. So at this rate, we're going to blast on through. I don't know how high it's going to go or how fast it's going to keep going up, but this is kind of flipping me out here. Now we can go back to last year and see what the increases were. Now here, now around the 1st of August last year, we had 2 weeks of really high increase. August 1st, that week it increased 4 parts per billion. And on the 8th it had increased another 4 parts per billion. And then there was no change the week of the 15th. And then slower, it still went up for a couple of weeks, but it started slowing down. Then it actually went down for a couple of weeks, and then we peaked out twice. Once on the 25th, and then it started going down, and then it jumped back up, and then we peaked out for the final time on October the 23rd, both at 1904.25, and we're at 1918. So we're way past where we peaked out last year. So is it going to keep zipping up? We seem to be a couple of weeks behind or stretched out from last year, so this could have been the 2 weeks of the big rise, and now it might start kind of slowing down. I don't know. Let's look at the 2019. That was the first year I was looking at this. No, that was so on the 10th, that was a couple of weeks there. It went up 4.5. Then the week of the 17th it went down 0.25. The week of the 24th it went up 3.25. And then it went down the week of the 31st. So it's hard to say. And then last year I started tracking it on a daily basis, and I report on a near daily basis on my Subscribestar page, and we'd love to have you join us over there. And with my small community, I do updates of some sort almost every day, and I do videos during the week, about 3 or 4 times during the week. And I'm finding I take a couple of days off from doing videos simply because of my schedule and different things. But I'm still posting things that are going on. So, I really like it over there. So there we are with methane. Now, let's run the CAMS data here. I have Saturday the 21st loaded, Arctic view and surface level. So we went up 5 parts per billion. Here's our color ledger. Now the data is for Saturday. The forecast period is Sunday through Wednesday. And first of all, notice these higher background readings. It's up past the green, up into the light green and into the yellows across a lot of Russia. This Yakutia area is where a lot of the wildfires are still burning in Russia, and across over into Siberia. We've got high readings down here in Russia and all over in western Russia too. We still have high readings in the Scandinavian area. And notice Alaska is really coming alive. See the green as the background, and then these higher readings popping up in the interior. Look at the waves we've seen this week. Large waves of methane moving out across the Barents Sea, Kara Sea, Laptev Sea, and up across the East Siberia Sea, Chukchi Sea, just kind of flinging around. And we're seeing green here. That's coming up through the sea ice. See this wave move out. We're also seeing this green wave move down. Lots of green waves now moving around, and that's a sign of higher methane as well. We've been seeing high readings on Iceland, see, popping off here. It's still billowing here at Komsomolets, and no one's reporting on that. No one has an answer for that. We've got our problem spot here in the North Atlantic off the coast of Canada. But you have to remember that every time we see an increase in methane, we're setting records from the day before or from the time before. We really are in no man's land, and we don't know what to expect. I don't know how this much of a methane rise is going to affect the heating of the planet. I just don't know, and with the speed of it. Depends on where we end up, I guess. Where we end up at the end of this methane season. Okay, here's the North Pole view. We can see the whole northern hemisphere here, or pretty much. See, UK, Ireland is covered up. We've got really high readings across Europe, well, east of France. Look, we've got some high readings in Spain. Coming down. Here's the Persian Gulf. Here's India See how that's filling up. Here's China. Now watch, look at this black wave move up from China across Korea. So this is a big release. When you see a big blob like that move out, look at that across the ocean there. See, it's spilling out over the coastline. That's some high methane. And then here in North America, we've got the usual places where it's popping up in really high areas, but you know, nothing like what we're seeing in China or India. See this green wave move down? Then we've got a light green. See the light green wave? See, that's spinning around in the Pacific. Then we've got a light green wave spinning. It spins out across the Atlantic. Then it looks like we've got another one spinning down. See this one, see this come out from the UK and from Europe. Watch this. Here it comes. Watch this wave. Those are signs of really high methane. When you see waves like that going across at surface level, you know you've got high methane. Now we'll look at the Antarctic. Now we're able to see the outline of the continent well because this background color is it's not this dark blue, which was 1800. We're at 1820 as the background color, 1820 parts per billion. Here, look, it's just sitting there on this western peninsula, and it's popping up on this west side too. And here at the Brunt ice sheet, look at that. It's just sitting there. It's like a continuous thing. Then we have a wave move down from South America. But we can tell the difference between what's coming up here. These are isolated, see, and then the wave comes down. So these are coming up from the Antarctic, or this coming up around the coastline. This is what is that? Larsen B ice shelf that collapsed a few years ago. But that whole area is just filled with methane. And then it goes up along the Larsen A. And then this whole area along the Brunt ice shelf. And there's another area that's popping up. You can't see it because of the white. That's the longitude, latitude measurements. But it's right there. There's another one popping up there. And the reading is like 1840 to 1860, I would say, because it's definitely a difference. You can see a demarcation from the 1820. Now we'll look at the global view. Here we can make out all of Australia. This eastern side, you can see the methane higher on this eastern side. Here's Perth down here on this southwest point. Here's New Zealand. See, it's streaming off of South America, see. I've seen it worse though, streaming. And then, see, we've got this higher color kind of moving across the Pacific, moves down and around. But these higher readings are kind of creeping further south. Now we'll look at 500 HPA. That's about halfway up in the atmosphere. Look at this. Now, see, it's almost solid green down here at the bottom across Antarctica. And see, we've got India here. Here's the highest readings, swooping down across India. Here's Southern Asia and China, and then higher readings up here in moving up into Russia. That's high readings there, and then we've got the reds from Canada across the Arctic. Here's total column. Look at this red swooping up, filling up Russia. Now these are, that's got to be from the fires. So the darkest, or the most concentrated, are these darker areas from India over to China, and then the red is the next color down. And see, that's spreading out across Africa. Got a little red spot here in Venezuela. So there's that. Now, I want to finish out. Before I get to sea ice, I'm going to finish out my pictures here. Here's sulfur dioxide for today. This is the global view. The highest reading is down here in the Philippines. Here it is at 500 HPA. See, right there. So it zipped up into the atmosphere, whether it was a volcano or earthquake, I don't know. And then Iceland has been releasing more sulfur dioxide because the volcano there. Oh, there's Iceland. Anyway, this is left over from the volcano. And then we've got some higher readings around coastline of South America. Here's ozone for today. We've got these holes that are opening up over the Antarctic. We'll look at that in a second. See the green how wide this green belt is around the middle of the planet. Anything below this solid yellow is thin. It's below normal. The solid yellow is 300 Dobson units. So you see all the greens. This is where it's thinned out because of the smoke from the fires. Here from Greenland, here over Canada. Anyway, here's the Antarctic today. We've got two areas that are in the danger zone, under 220 Dobson units. Where this is, when they put it in the black line, that's in the danger zone. But the whole continent is less than the yellow. So we've got aqua, and then the blue-green, and then the chartreuse. So this whole western side is in the danger zone, and a little bit on the eastern side today. Here's the Arctic view of the ozone. We can see the thinning is over the Laptev Sea right now. And also over Greenland and over the Greenland Sea, over Canada, and here, huge area of Russia, and Russia there. Here's the smoke from today. And this is where it's blown around. Now, here it is from the west coast coming across. And then it blows out over the ocean too. This is smoke that has come across the Atlantic over to the other side of the world, so you get some of our smoke over there. Look at this. This is the global view. Look at South America. They've got extra smoke. I don't know what's going on down there. Here's Africa. That's all of those. Now we'll start on sea ice. We'll go through our slideshow first. This is from Climate Reanalyzer for today, sea ice and snow cover. We'll zoom in here. The Baffin Bay is clear. Hudson Bay is clear. This east side of Greenland is clear. Now this northern part just above Greenland is really taking a beating. It's just unbelievable, just coming apart. This east edge is falling apart. We still have a little bit of ice around Severnaya Zemlya. This northern edge is, well, it's spreading out. It's coming apart, but it's kind of spreading out. It's not really refreezing, and you'll see on the extent chart from National Snow and Ice Data Center, it shows the line kind of flattening out, but I think that's because the sea ice is, as these leads break apart, the pieces of ice start spreading, coming apart, and so the extent area, it makes it look like it's a bigger extent, but it's really not. I think it's false to believe that. This western side in the Beaufort Sea is really going down. You can see how thin it is over here, and you'll see on NASA Worldview there are lots of areas with open water there. So let's go through our slideshow for this week. Here we were last Sunday in the show. So we'll just click through. That was the 15th. Look at the change to the 16th. Here's the 17th. I'm kind of watching that Beaufort Sea area. Here's the 18th, 19th. That's a big change. 20th, 21st, and then today, 22nd. So that's what we've got there. Now we'll go through the Navy model, U.S. Navy. This is for sea ice thickness. This is the Arctic view. Here's the color ledger on the right. It goes from 0, which is white or nothing, down to gray, up through backwards in the rainbow, up to dark red, which is 5 meters. I'm not seeing any red, or I'm not seeing yellows even. We'll see what we see here. We're mainly seeing purple or lavender. This lavender is about 1/2 meter thick, and this, see the whitish, that's less than 1/2 meter thick, and there's a lot of open water there. The dark blue is about 1 to 1.25 meters thick. That's this area here above Greenland. And the dark aqua is about 1.5 meters thick. And then as it moves up into the brighter aqua, that's about 2 meters thick. And then if we saw green, that would be about 3 meters thick. So here we go. Fasten your seat belts. Here's this hole that's opened up above Greenland, and then the ice above there is really deteriorating quickly. Here on this eastern edge, this is on quadrant 2, we can see holes opening up. It's actually pulled away from Franz Josef Land. You'll see on NASA Worldview that there's just very little ice in right around this 80 degree north latitude there. Here's in this North Kara Sea, here's what's left of that little thicker ice, and it's kind of huddling next to Severnaya Zemlya. Then here it's clear in the Laptev Sea, and see this edge is just kind of evolving. See the whitish areas? That's where it's thinning down. And you'll see this week we had a lot of thinning, and this is just down to a little nub what had been aqua, thicker ice here in this East Siberian Sea and here. And then this is what's left of the multi-year ice that was left over last year at the end of the melt season. It was right above Canada here, and then we watched it with the models sliding down over the winter time, and then it's been just being churned apart here in the Beaufort Sea. So that's what's left of that. Not much at all. And then here in quadrant 4, this is the thickest and what's left, and we've got a little wisp of green here along the coastline there. But it's mainly here's some brighter aqua a little bit, and then dark aqua here, and then it's just disintegrating down into the thinner and thinner readings, and it's coming out through these tributaries now. And we've got a little bit of thicker ice here above Greenland, but it's melting and coming apart, and it's coming down through the nearest strait, since that opened up too. Typically, the melt season ends around mid-September. I don't know if that's going to be the case for this year. Everything is atypical this year. And the methane is about 2 weeks off with the readings later, 2 weeks later than what we saw last year. So, it could be that this will keep on melting into September and October. Here's the 30-day animation. The data goes back 3 weeks, and the forecast period goes out a week from now to the next Sunday, the 29th. So let's see what this model is forecasting. And we've been seeing some colder air over the Arctic this week, but that's not keeping the ice from melting. It's still melting fast. Look at this, moving down. Watch it, just sliding out. Okay, I've stopped the model. Here we are on the 29th. See, next Sunday. So we're still seeing some ice here by Severnaya Zemlya. It's still thinning. We're not seeing a lot of change in the extent here. Kind of holding, and we still have this big hole over Greenland. And it's just still thinning out and moving out. So the big question, I guess, will be how much of this lavender ice will be left at the end of the melt season, and the purple ice. I mean, it's really holding on, I think, a lot better than I thought it would this year. But like I said, we've had colder air over the Arctic. I don't know if that was manufactured to kind of keep the ice from melting as fast. Anything is possible. I mean, they can certainly control the weather. We've seen that. So we'll see what happens. Here's the Beaufort sea ice thickness. Now Alaska is down here at the bottom. Canada is over here on the right. Here we are today. So here's what's left of that. It looks like a little ribbon of that thicker multi-year ice. Here's the 30-day animation. Watch the thinning here along Canada. And you can see the ice moving out. It's crazy. Here's some greens and almost a yellow up here. So these are about 3 to 3.5 meters thick. Just small areas. I think I saw a little red in there, but that was during not now. Let's see, I didn't mean to do that. Let's stop it. There we are on the 27th. No reds there. Here we are today. No reds there. There's just a lot of open water where you see this whitish areas. Like there. Now we'll hop to the Antarctic. This is sea ice thickness for today. Now here we see the ices around the continent. Sorry. This most of this melts during their summertime, and then it refreezes during their winter time when it's in the dark. And it's been thickening. See, it's into the blues and aquas now. But there are still a lot of areas that are thin or no ice right around the coastline, and I just don't know why that is, unless for whatever reason it's warmer around the coastline. Let's see. Look at that. Now the earthquakes that have been happening in the South Atlantic have been right up here. They're running parallel to the South Sandwich Islands, which are about right in that region. Here's the 30-day animation. So again, the data goes back 3 weeks. The forecast period goes out a week from now. So we're seeing thickening happen mainly. Well, especially this week. Okay, there it is at the end. This little area is Pine Island Glacier. That's like no ice there. This is thin ice around Thwaites, and this is the Ross ice shelf here. See, open right up at the ice shelf. And then this is the Amory ice sheet over in this area, and it's quite thin around there. Now here's the Western Peninsula. This is the area where we saw methane coming up, and here along the Brunt ice sheet. See, that's coming up through the ice. So there's that. That's all of those. Now let's move on. We'll look at sea ice index next. This is from National Snow and Ice Data Center. This is as of yesterday. This is sea ice concentration, and you see all this dark blue. This is where it's really coming apart on this western side. Huge area. It just looks like that's just ready to go. And above Greenland too. Here is the extent chart. And they count any little wisp of ice as extent. Now this dotted line is 2012. This blue line is this year. This gray line up here is average. Now we had been running pretty much parallel to 2012, or right along the same line, until a few weeks ago, and then it slowed down, and it hasn't stopped going down, but it slowed down a lot, and so we can see that we're quite a bit above 2012. This is extent, millions of square kilometers, and this is that's six there, that line. So it looks like it's just under 6 right now. Uh-oh, I didn't mean to do that. I forget when I'm on a website and when I'm on a picture. Okay, we're on the website. So let's go to the Antarctic daily view. Concentration. Let's see the different shades of blue showing the concentration. Here's their extent chart. This blue line is this year. The dark gray-green line is last year. And this light gray line is average. And it had started refreezing early in the season this year. And so it's still above average a little bit. It's still above where we were last year, but it's slowing down. So it looks like we're going to end up with about the same extent as last year, which was above average. But that doesn't mean anything. If it's melting, you know, it doesn't mean the extent is a moot point if it's so thin and going away, or if it's flowing off of the land into the ocean and pushing it out and making the extent. It means nothing. Here's the Greenland ice sheet today. The salmon areas are where it's in melt today. See around these coasts, the western side, this whole western side, eastern side. This is cumulative melt extent for this year. So the summit is right up in here. Cumulative melt days. So we're seeing melt going on deep inside the interior. See, look at all of this. Very little white where it hasn't melted at all this year. Very little. And look at all of this where it's the cumulative days. Look, they're going up into this kind of reddish purple area, which is what, 75 or 80 days of melt. Here's their chart for melt extent. As of yesterday, and see, it peaked out. It's peaked out twice above 50% that was melting all at once. And right now, it's about at 10%. And this dotted blue line is the average. But, see, it's way above what average is and what they've seen in the ranges before. Alright, now let's look at Climate Reanalyzer. Here are the 2-meter temperatures, maximum temperatures. We're seeing blues, see, over a lot of the Arctic basin, and that's this color here, which is freezing, 0, which is good for keeping the ice, but it's a little unusual. Then we've got greens right next to it. But it's still melting, even with the colder air. Because you've got the sunlight, you've got radiation, you've got warm water underneath, you've got warm water next to the edges. Look at all these whites. Here's 2-meter temperature anomaly, and we can see Russia's coming back into the red here, and they're in brown over here in eastern Siberia. Greenland is in the brown. We've got some blues over the Arctic, a lot of browns though. Look at the browns coming in. Look at all these blues from Alaska down through Canada, and then browns on eastern Canada. Look at Australia, you're in the brown. Worldwide, we're up 0.1 C higher than normal. Northern Hemisphere is up 0.7 C. The Arctic is up 1.5 C higher than normal. Tropics are up 0.5 C. Southern Hemisphere is down 0.4 C. And the Antarctic is 4.4 C lower than normal. Here's precipitation and clouds. The green is rain, so you can see it's raining here in the North Kara Sea next to Severnaya Zemlya. So it's raining right over that thicker sea ice that's huddled up there. And then we've got some rain across Alaska, some rain across Russia, I mean, whatever rain we can get is good. We need rain here in the western U.S. Then we've got snow across the Arctic basin here. It's raining here on the southern tip of Greenland. Look, it's raining up here in northern Canada. And I'm not going to report on all the severe weather. There are other people who do that. It's too much for me to do that in addition to keeping up with methane and sea ice. But I'm saying prayers for everybody. Here are the sea levels. We've got a low system over the Beaufort Sea. It's at 996 millibars right now. So it's not hugely destructive, but anything over that sea ice will be tearing it apart. Here's another low over Canada, and so on. Here's the storm over the northeast. It's at 1,004 millibars as of this picture. Here's the jet stream. Look at these broken up pieces. Look at this. That's crazy. Oops. See, there's the low. Here's the southern hemisphere. There you go. Broken up. And schizophrenic. See, one up here, one down here. We saw sea ice and snow cover. Here's sea surface temperature anomaly. Now this is a really important one to look at. So we're seeing that these, where the ice has melted, see how fast this water is heated up. And it's up, this pinky white color is 6C higher than normal. We're seeing that. And the reds here in the Kara Sea, we're seeing that along the coastline in the Laptev Sea, and then browns. And even here in the Beaufort Sea, see along this Alaskan Canadian coastline, see it's going back up into the browns. Look at Greenland. Look at the reds around there. And there are methane deposits all around in the Arctic and around Greenland. So we could have a blowout from anywhere where we're seeing reds like this. Look at, here's our blob in the Pacific, that's coming back. Look at all of these reds and browns. The Atlantic, that is not good. Here we are with the flat view. Now it calmed down around Japan. That had been red for so long, but we've got red up here in the Okhotsk Sea, and brown, look, around Kamchatka, and see these interior seas, they're all going higher. Here's the Caspian Sea, that's dark brown. Here's the Pacific. There's that red blob. Worldwide, we're up 0.5 C, higher than normal. Northern Hemisphere is up 0.7 C. The North Atlantic is up 0.8 C. North Pacific is up 0.6 C. Southern Hemisphere is up 0.3 C. And the Equatorial Pacific is up 0.2 C. I don't know why they won't put the Arctic as a separate one. I think they really need to, because, you know, North Atlantic only goes so far. I mean, are they counting this coastline around Russia here in the North Atlantic higher readings? I don't know. I don't know how high up that North Atlantic goes. And I don't know if this area in the Laptev Sea, if that can be counted as North Pacific. I don't know. Or it's just counted in Northern Hemisphere, I guess. Anyway. It's not looking good. Now we're ready for to take a peek at the sea ice. NASA World View. This is sea ice concentration. We'll turn on the blue marble layer. That takes away the clouds so we can get a better picture of this. Look at these holes opening up over Greenland. See the green? That's really deteriorating fast. Here's his eastern edge. See, there's a big hole there. Here's that thicker ice by Severnaya Zemlya. We can see that's coming apart. See this northern edge? It's it's not put together very well, and see all these colors. That's just like almost nothing. When you get down to the purple, that's pretty much almost nothing. And then look here in the Beaufort Sea. This is all of the deterioration. Here are some holes here, but that's coming down. Let's see all these reds. So that's what we've got today. Let's go back to last Sunday and we'll click through. Here we were last week. So we'll click through. Here's the 16th, 17th, 18th, 19th, 20th. Yeah, you can see this line coming down. It's like this is breaking off here. Here's the 21st. Here we are today. See, here's that hole that's opened up. This is in high melt. Look at that. Now we'll turn the clouds back on and take that layer off. Now zoom out. We still have smoke. Here's smoke in Russia and smoke that's streaming out across the Aleutian Islands. It's not as smoky as it has been up here. But let's start down here at Greenland. Let's start in the Baffin Bay. See this? This is that west side. Look at Here's the ice sheet. Here's the rain on this southern point. Here's the nearest strait. Now this is an excellent view today, no clouds. See this just little wispy ice where it's melted and flowing out. Look, this ice is flowing down. See? Here's the Lincoln Sea, and here's the coastline along Greenland. This is the area where we've got a little bit thicker ice piled up there, but see, it's deteriorating here. See that? And it's deteriorating as you come across Ellesmere Island. You'll see there are the ice pieces. And then here's the Greenland coastline. Watch here. Look, here's the hole. See this whole part here. Now you can't really tell. There's a big cloud there. Let's go back. Here we go, yesterday. Look. See, there's the hole. See, that's open water. Right up to the coastline, and these inlets, those are melted. Look at this. See? That's what I'm talking about the ice breaking apart. And it spreads out when it does that. And here's this east side. There's just a little wispy part here. That's all. That's open, see? Let's go back to today. Here's Svalbard. Here's the ice edge here. See? There's the ice. Here's Franz Josef Land here. Here's ice edge. Ice edge. Look. This is well inside 80 degrees. This is what? 83 degrees north latitude. There's the edge. See? Let's go. Now here's Severna Zemlya. Here's the rain. Here's where that thicker ice is. Let's go back. I've got something to show. Now this is a good view. This is from the 20th. Look at this Vovolov ice cap. So you can see this is where the ice is flowing, pouring into the ocean there. And this is the sea ice where it's melted around the island. But this is, right, see that tongue? That's the ice pouring out. And all of these ice caps are diminishing very fast. Now, this is Komsomolets Island right here. So right around this coastline is where we're seeing the methane billowing on CAMS. That it's been billowing since January of last year. Okay, let's go back to today. Okay, here's Tamir Island. Peninsula, not island. Now this is the Laptev Sea. There's no ice there. It's totally covered with clouds. We can't see anything. Here's New Siberian Islands. There's no ice along here. Here, there's a little fringe of ice here. You can see the little ice cubes here. Here's Wrangell Island. Then here's the Bering Strait. Here's Alaska. Look at all these clouds. See, there's no ice along the coastline. That's all melted away. This is Canada here. Now, right down here, we can get a peek. This is the Beaufort Sea. That's what it's looking like now. See? That's where it's breaking up. This whole west side is just really coming apart. See? Look. See all this open water? Some years the Beaufort opens up early. Some years it keeps ice. It just depends. Oops, what happened? Oh, when you go in, it turns into a cloud. How weird. Let's see. Look at that. It's like it blocks it out. It's a different image when you zoom in. Wonder what that's about. Oh well. Let's see here. Here we go. So here's that low pressure system that right here. You can see it swirling. See. That'll do a number on the sea ice. Here's Ellesmere Island. Hard to see much there. Here we go. You can see it's breaking up. Let's go back. here we go. This is on the 20th. This was a better view of the Beaufort. Look at this. That's kind of pathetic. Look at that. So this, where we see all this open water and just the little tendrils, that's like equivalent to the light lavender on the Navy model for sea ice thickness. Look at that. Here's Barrow. Here's ice. There we are, back to today. There's that. See, there's the edge coming down. And then it's this whole area along this west side is all coming apart. So there's that. Now we'll take a peek at earthquakes. This is still rocking down here in the South Atlantic. We just had a 7.1 this afternoon. This came in at 2:33 Pacific time, South Sandwich Islands region. And we had one up here in the Greenland Sea of 4.5. This happened at 6:42 this morning. We can see that's right in between Svalbard and Greenland. That's in the Fram Strait. Look at all this plate movement. Lots of activity. Lots. A lot of these came in after this 7.1 hit, like one south of New Zealand, 4.0 Riverton. Oh, it's just right on. See, it's just south. So we'll go through these pictures. So I took these this afternoon before that 7.1 hit. There were 330 worldwide. Here in the lower 48 we've got 189. Southern California has 27. Searles Valley Ridgecrest has 17. Now this is an uptick. We've got 93 in this picture, and it's from Tonopah over. This is Mammoth Lakes, but they're mainly swarming up here still at Colville. Now that Calidor fire is just west of there, and it's moving up towards the lake, Lake Tahoe. So most of them are here in this cluster, and the largest was a 3.2 at Markleyville. We only have one on the San Andreas fault line, a 2.1 at the pinnacles. We've got a 27 at the geysers. Then this is Pacific Northwest over to Yellowstone. Only one in the Yellowstone area, which is this 0.8 at Lincoln, Montana. And then we've got 4 here in Washington. The largest was a 2.3 at Hamilton. West Texas had 3 today, 2.8, 2.5, and 2.2. Oklahoma is showing 13. They had a 3.9. That's a larger one up at Jefferson, Oklahoma. And then they've got a little cluster going on here at Quinton. Here was a 1.7 near Rochester, New Hampshire on the east coast. Here is that 4.5 in the Greenland Sea. And we'll be seeing more and more of these Arctic earthquakes as the ice melts and shifts the weight on the land. The tectonic plates bounce up and down, and it's called isostatic rebound. So we'll be seeing more and more of this. Puerto Rico had 11 today. We've got one at 4.5 at Baltazar, Loxicha, Mexico, or Loxicha, Mexico. Look at South America. We've got 7 in this picture. Down here in the ocean, a 4.7 on the West Chile rise. The largest was a 5.0 here in Peru, San Fernando. And then we've got 4 lined up all along this west coast. These are in the 4s range. Here in the South Atlantic Ocean, there were 8 here. We had a 6.8 down here yesterday, and that's included in this picture. And then we've got 4s and 5s after that. Hawaii showing 31. Alaska showing 70. The largest was this 4.9 at Adak down here in the Aleutian Islands. In this picture we have 7. We've got a couple down here at Fiji and Tonga. We've got, 4.6 south of the Fiji Islands. That one was 437 kilometers deep. And then 4s, these are all 4s. Indonesia, we've got a 4.8 Kermadec Islands. And so the rest are 4s all around Indonesia. We've got 4 in this picture. We've got 3 at Japan, 1 in Taiwan, 4.4 at Eugene, Taiwan, 5.2 Hisaki, Japan, 5.3 Nami, Japan, and 4.4 at Ichinohi, Japan. And then we've got a 4.6 on land at Moniwa, Myanmar. And at Mongolia, Mongolia, we've got a 4.5. And this is an area that we get a lot of earthquakes here. And then the 7.1 came in a little later, 2:33 this afternoon, here in the South Sandwich Islands. That's all of those. So let's look at the website now. Let's see what else has happened down here. How many? We've got 10 here now. So since that 7.1, we've had a 5.0 come in. The islands are just to the west of these lines. And see, it's right on this red line. And 3 plates come together here. So it's a quite active area, but normally we don't see huge quakes popping off all the time down there. Here's a new one. 4.3 Kyrgyzstan. Idarkin, Kyrgyzstan. Here's a new one. 4.4 Durab, Iran. And then, see, this whole Colville area is just, that's not good. Here's a new one. 1.6 Austin, Nevada. Here's a new one. See, on this fulcrum point. 1.6 Petrolia, next to the Juan de Fuca plate. And so on. Oh, I wanted to show Quentin. This is kind of bothering me. But they've got 9 here now at Quentin, Oklahoma. They've had a couple, 3.7. That was the largest one. We normally don't see large ones here. And then 2 3.0s, and then some 2s, and then it's going down. So something's going on at Quentin, Oklahoma. So there's that. So that's my report for the week. So I'm going to finish up by continuing reading out of the Bible. I do this reporting and everything because I believe we are in the end times, and by tracking all of these events, it helps us realize how much closer we are to the end, and hopefully realize that we need to get our spiritual houses in order before it's too late. And time is so short. I don't know how long we have. God knows. But we have to keep living day to day, as if we're going to be here. We can't count on, the methane bomb going off next week and heating the planet up so fast that everything goes within 6 months. We can't count on that. But we can count on God's love, God's forgiveness, and His acceptance of us into the kingdom if we only believe. That's all it takes, is belief. So tonight we're reading out of Hebrews. These are Paul's letters to the Hebrews. Hebrews chapter 5. For every high priest taken from among men is ordained for men in things pertaining to God, that he may offer both gifts and sacrifices for sins, who can have compassion on the ignorant and on them that are out of the way, for that he himself also is compassed with infirmity. And by reason hereof he ought, as for the people, so also for himself, to offer for sins. And no man taketh this honour unto himself, but he that is called of God, as was Aaron. So also Christ glorified not himself to be made an high priest, but he that said unto him, Take art my son, today have I begotten thee. As he saith also in another place, Thou art a priest forever, after the order of Melchizedek, who in the days of his flesh, when he hath offered up prayers and supplications, with strong crying and tears unto him, that was able to save him from death, and was heard in that he feared. Though he were a son, yet learned he obedience by the things which he suffered. And being made perfect, he became the author of eternal salvation unto all them that obey him, called of God and high priest after the order of Melchizedek. Of whom we have many things to say, and hard to be uttered, seeing ye are dull of hearing. For when for the time ye ought to be teachers, ye have need that one teach you again, which be the first principles of the oracles of God, and are become such as have need of milk, and not of strong meat. For every one that useth milk is unskillful in the word of righteousness, for he is a babe. But strong meat belongeth to them that are full of age, even those who by reason of use have their senses exercised to discern both good and evil. Hebrews chapter 5. And we need to pray for discernment. We need to ask for God to help us with that so we're not deceived. That's a big one. So I'm praying for all of you. I hope you have a good week. And I love you all. Until next time, God bless you. Go in peace, and I will talk to you soon. Good night.